Hello students, this is Mr. Ezra. Today we are going to begin our unit on statistics. We're going to be talking about measures of central tendency and variation. Um, this will be a bit different from the algebra we've covered so far this year, and hopefully you'll find the break from algebra refreshing, though we will see a little bit of algebra in our statistics unit. First, today what we are hoping to do is to talk about something called central tendency, which you have actually learned in the past, and something called variation, which is something you've learned probably a bit in the past. And we also want to talk about how to successfully identify outliers in data and describe how they affect the data. Let's start by talking about measures of central tendency. So this is when we talk about measures of central tendency, we're talking about a measure of the center of the data. What is the middle of the data? What's the center of the data? And there are, generally speaking, two main ways that we do this, and a third way that you can sometimes use. And those are the mean and the median are the two main ways that we measure central tendency. And sometimes you can also use the mode. Here we have some data, a deer, the number of deer at a feeder for each hour. The first hour there were 3 deer, and then 0, and then 2, and then 0, and then 1, and then 2, and then 4. We want to find the mean, median, and mode of this data. To start with the mean, you probably remember how to do this. This is what you, for a long time, have called the average. It's where you add up all of your data together, and you divide by how many pieces of data you have. So if we are adding 3 plus 0 plus 2 plus 0 plus 1 plus 2 plus 4, that gives us the sum of the number of deer at the feeders. We then have to divide by how many hours that we measured, and that's 7. So 12 divided by 7 gives us a mean, or an average, of about 1.7 deer per hour. To find the median, we first need to put our data in order from least to greatest, because the median is the middle number. You probably remember that. So if you count into the middle here, you'll find that the median is 2. There are 3 data values lower than 2 and 3 greater than 2. It is the middle number. And finally, mode is the outcome that occurs the most. The thing about the mode, and why it's sometimes not used as a measure of central tendency, is you can have no mode. You can have no outcome that occurs the most, and you can have one mode. You can also have more than one mode. In this example, the most common results are both 0 and 2. They both occur the most, so we have to report them both as the mode. I want to show you also how to do this in your calculator, and I would encourage you to get your graphing calculator out and to practice putting this stuff in with me. So we basically want to get this data right here, and in our calculator you're going to find the stat button, hit edit, and then enter this data into what we call list 1. So I'm going to get my calculator out, and I'm going to hit the stat button, and I'm going to click enter on edit. And you see L1 at the top here. This is list 1. This is where you want to put your data, in list 1. Okay, and then once you get your data in list 1, it's always there. I can quit, come back to it, click edit, and my data is still there. If I want to clear this data out for some reason, I will arrow up, hit the clear button, not the delete button. The delete button will delete the whole list, but we want to clear it out. So we hit clear and then enter or down, and that will clear out this list here, make it a little bit nicer. So let's see, clear, boom, it's gone. Okay, now if we had some data in there, the next thing that you want to do is hit the stat button, click calc, and 1var stats. Now, if you have your data in list 1, you can hit enter here, but if it's in another list, like I have some data in list 2, it's not the data we were looking at with the deer, but a different set of data, then I want to hit second 2, and that's going to put in L2, and it'll do the one variable statistics for list 2. And here I have a whole bunch of statistics that I'll need, like we'll learn later. This is the mean, this is standard deviation, sample size. If I arrow down, I get the minimum, the first quartile, the median, the third quartile, and the max. So from here on out, whenever I talk about putting data in your calculator, that's what you want to do. You want to go to Stat, Edit, type the data in, type the numbers in, hitting enter after each one so it's all in one list, and then do Stat Calc 1 bar stats, and it'll give you everything that you need. All right, so let's try another one, and please feel free to use your calculator on this. If you don't have a calculator, what you're going to have to do is do it by hand. All right, hopefully you paused the video and tried this problem, and now we're going to talk about the answer. So the mean, you would add those 4 numbers together and divide by 4, and you get a mean of 6.5. For the median, you should put them in order from least to greatest. Since there are 4 numbers, an even number of numbers, the median is between these 2 middle numbers. So we're going to average those together to get the median. 6 plus 8 divided by 2 is 7. And the number that occurs the most is, well, there's not one, right? There is no mode here because no number or no outcome occurs more than any other. Now, let's also review something called a box plot or a box and whisker plot. Box and whisker plots are nice because they show the spread of the data. They give us a good picture that let us know how spread out things are. And there are five or six key parts of a box plot. First, the minimum and maximum are at both ends of the box plot, with lines coming from them to the third quartile and the first quartile. Between those these first quartile and the third quartile, you'll have a box, and the median is going to be represented in the very middle. Now, I want to go ahead and say that this box represents, the length of this box represents the interquartile range. You might remember from previous classes that the range is the distance from the minimum to the maximum. Well, the interquartile range is the distance from first quartile to third quartile. Another thing that we'll talk about later that shows up on box and whisker plots are outliers, and we'll add those to our discussion in just a little bit. The quartiles are like the medians of the lower and upper halves of the data. They're the middle of the bottom half and the middle of the top half, and they help us to break our data into quarters, a first quarter, second quarter, third quarter, and fourth quarter. If there are an odd number of data values, you do not include the median in either half. So for example, if I have 7 data values and that fourth one in the middle is my median, I would ignore that middle number when I'm looking at my bottom half and my top half. The interquartile range is just the difference between the first and third quartile. You subtract them, and this represents the middle half of the data. So let's make a box and whisker plot with this data here. So you might remember that in your calculator, you can hit Stat, Edit, and enter this data into list 1. You don't have to put it in order first. You just have to make sure that you have the numbers in list 1 correctly. When you do 1 var stats, again, it's Stat, arrow to Calc, and then choose 1 variable statistics. It will give you, if you arrow down, everything that you need, or almost everything that you need, to build a good box plot. So when we talk about how to do this, certainly I want you to practice trying to do this and see if you can do it, see if you get what we get. The other way to do it is to do it by hand, and I'm going to kind of show you both approaches today. We'll kind of have the in-calculator commands over to the side, and then we'll do it by hand in the middle here. So we would enter our values into our calculator, find the minimum, maximum, medians, and quartiles using 1 var stats. And if we don't have a calculator, we just have to do it by hand. So the minimum is 4, maximum is 10. 7 is the middle number. Remember, when we have one middle number, we don't use it when we look at the bottom half and the top half. So this is our bottom half here from 4 to 6, and our top half is from 8 to 10. We've got to find the middle of each of those to find our quartiles. The first quartile is going to be the middle of the bottom half. It's halfway between 5 and 6, so you say 5 plus 6 divided by 2 to get 5.5. The third quartile is between 8 and 9, so 8 plus 9 divided by 2 gives you 8.5. So, to get this on a graph, we want to take those numbers, the minimum, the first quartile, the median, the third quartile, and the maximum. Those 5 numbers, we call it the 5-number summary. We want to plot those as dots above a number line. So we need a number line that gets from our minimum to our maximum, and then we want to plot all of those important points above on the coordinate plane. After doing that, we should connect the dots from the outsides in, from the maximum, minimum to the quartiles, make a box from the first quartile to the third quartile, and add a line for the median. You've got a beautiful box plot. I'd like to also encourage you, if your numbers have meaning, that you add a label under the number line so that we know what the numbers represent. By the way, our interquartile range would be the third quartile 8.5 minus the first quartile 5.5. So our interquartile range is 3. That would also be the length of the box in the diagram. So that box, the size of the box, the length of the box gives us the interquartile range, as well as subtracting Q3 minus Q1. So you try this one. Use your calculator or do it by hand. See if you can make a box and whisker plot of this data and then find the interquartile range. Hopefully you've paused the video and tried this out. Let's see how you did. If you are using your calculator, you do not have to put these in order. You just type them into list 1. If you're not using your calculator, you need to put them in order first, and then start finding medians and quartiles and maxes and mins. If you're using your calculator, you'd put your data into list 1. You'd use one variable statistics to find the 5-number summary. In this case, we had 2 middle numbers. They were both 14, so 14 plus 14 divided by 2 is still 14, so the median is 14. Since the median is technically between these 2 middle numbers, we are going to include those 2 middle numbers as a part of our bottom half and our top half, because the median is between them. It's not one of those 2 numbers. The same thing happened when we're trying to find our first quartile here. We had 2 numbers, we averaged them together to get 13. We had 2 numbers, we averaged them together to get 18. So now we've got our 5-number summary. Minimum 11, first quartile 13, median 14, third quartile 18, and maximum 23. We're going to draw a number line that includes the numbers from 10 to 25, and we're going to plot those 5 numbers as dots above that number line. That's the very first thing you do, is put those dots up, and then we'll connect the dots from the outside in, from the max and min to the first and third quartile. We're going to draw a straight line, a box from first quartile to third quartile, and a line in the middle of the box for the median. To find the interquartile range, we subtract third quartile 18 minus first quartile 13, and we got an IQR of 5. So we have 2 data sets here, 19, 20, 21, and 0, 20, 40. They both have the same mean and median. If you find the mean and median of each of these data sets, it's 20. It's the middle number of both, and it happens to be the average of both, but these sets are pretty different from one another. So the mean alone, or the median alone, the measure of central tendency alone, is not enough to describe the data. We also want to talk about how spread out the data is from that mean or median. And we call this variation or variability. A measure of variation is a value that describes the spread of the data set. You have probably used measures of variation before, like the range and perhaps the interquartile range. But we also want to discuss the variance and the standard deviation. Some symbols that you should get comfortable with. The symbol that we often use to represent the mean is x with a bar over it. We call it x bar. There are other symbols that we might use for the mean, but this is what we'll use for this course. The Greek symbol for standard deviation is the lowercase Greek letter sigma, little baby sigma here. It's like a little O with the tail. And again, this isn't the only letter that we use for standard deviation, but it's what we'll use in this course. The variance is the standard deviation squared, so we just use that standard deviation symbol squared. And the variance is the average of the squared differences from the mean. The standard deviation is just sigma, and it is the square root of the variance. So they are related to one another. If you know the variance, you can take its square root to get the standard deviation. If you know the standard deviation, you can square it to get the variance. Low standard deviations indicate that data are clustered near the measure of central tendency, that your data is not very spread out. It's kind of concise and close together. But a high standard deviation can indicate that things are very spread out in your data set, that there are lots of data values that are very far from the center. To find variance in standard deviation, I really want you to use your calculator for this, and you do it the same way that you do for finding the other measures we've talked about. You put your data in list 1 or another list, and you use one variable statistics of that list, of list 1, in order to find the mean and the standard deviation. So you want to look for this sigma symbol when you're doing that. Once you find your standard deviation in your calculator, you can just square it to get the variance. If we're going to do this by hand, we're going to have to do a little bit more work. So if you don't have a calculator with you, it's going to take just a little bit more time. So let's find the mean and standard deviation for this data set of the number of people getting on and off a bus for several stops. First, we find the mean. We add all of those numbers together and divide by how many there are, and we find the mean is 7. Now, the variance is the squared distance from the mean. So we have to know the mean first. In the calculator, remember, enter your data in list 1, choose one variable statistics to get the mean and standard deviation. Now that we know the mean, we need to know how far the mean is from each data value. So I like to make a table. I put all of my data values in the table, all of my x values, and then I subtract them. I subtract the mean from all of those data values. So 6 minus 7 is -1, 8 minus 7 is 1, 7 minus 7 is 0, all the way to the end. And then in order to get variance, I have to square all of those, what we call deviations from the mean. And what you notice is that the squared deviations are all positive, and that's one important element of these squared deviations, because if I added all of the deviations together, I would always get 0. They always add to 0. But adding the squared deviations, I don't get 0. I get something that I can use, and that is exactly what we're going to do. We're going to add them up and divide by how many there are. So since there are 9 data values, these are the squared variations. I add them up. I basically average the squared deviations. Once I find the squared deviations, I add them up, divide by how many there are. That is my variance, 3.3. To get standard deviation, I take the square root of the variance. Square root of 3.3 is 1.83. So these are approximations for our variance and standard deviation. When you are using your calculator, you almost do this in the other direction. 1var stats gives you the standard deviation. You'll see a little sigma symbol in there. And you have to square the standard deviation to get the variance. I encourage you to practice that and ask questions if you have questions. So here the mean is 7 people, and the standard deviation, or the average distance from the mean, is about 1.83 people. Try this one on your own, see how you do. All right, remember you can use your calculator to find this, but without the calculator, without the graphing calculator, you've got to add all your data together to get your mean first. In the calculator, you put it in list 1, do 1var stats. After we get the mean, we subtract it from all of our data and square all those deviations from the mean and average them. The average is 2.64, and then we take the square root to get the standard deviation. In our calculator, we would get the standard deviation and square it to get the variance. So if our standard deviation from our calculator is about 1.6, we would square 1.6 to get the variance of 2.64. So there was an average of 1.4 stops, with an average distance from 1.4 stops, an average spread of 1.6 stops. Another thing we want to talk about are outliers. Outliers are extreme values that are much less or much greater than the other data in your data set. They have a strong effect on the mean and standard deviation. The mean and standard deviation are not resistant to outliers. If an outlier is the result of an error, you wrote the wrong number down, you typed the wrong number in your spreadsheet, uh, or you got it from the wrong population, we usually remove it. I mean, if there's a reason to remove it, we do. But you have outliers on just as part of regular data sets, and we don't remove them in those cases. We just understand that they have a huge impact on the mean and the standard deviation. There are different ways to determine whether a value is an outlier. The most popular one in the statistics world, at least in an intro level, is to look for data values that are more than 1.5 times the interquartile range above the third quartile or below the first quartile. The guy who came up with this formula was asked, what's so magic about 1.5? And he said, well, I tried 1 and it wasn't enough, and I tried 2 and it was too much, so I settled on 1.5. And it's what we use to this day, that magic number of 1.5 times the interquartile range. Is how far we need to go above Q3 or below Q1 before we start to find outliers. So an example of an outlier. In the 2003-2004 American League Championship Series, the New York Yankees scored the following number of runs against the Boston Red Sox. We want to identify the outlier and describe how it affects the mean and the standard deviation. So first, you probably can see that the outlier is likely to be 19, but just guessing that it's an outlier is not good enough because we could be wrong. We have to justify that it's an outlier. To do that, we want to enter the data into list 1, find the quartiles, and remember you do one var stats, but you have to arrow down to get to the 5-number summary. So we have a Q1 of 3 and a Q3 of 6. We're going to subtract those two numbers. 6 minus 3 is 3. So this would be the whole 1 var stats from your calculator altogether. If you arrow down, you'd see all of those numbers. So we want the interquartile range and the first and third quartile. We are going basically the formula for outliers is to take the third quartile and add 1.5 times that interquartile range. In this case, that's 6 plus 1.5 times 3. This gives us our upper boundary. Anything larger than this upper boundary would be considered an outlier. Anything in our data set greater than 10.5 would be considered an outlier. So you may have noticed a slight change seen on the screen here. This was a plus sign by mistake, so please fix that if you've already written this down in your notes. The lower boundary would be the first quartile minus 1.5 times the interquartile range. We want to go below Q1. We want to know what's a lower outlier boundary. So after subtracting, I got negative 1.5. Anything in our data set less than negative 1.5 would be an outlier. Well, anything less than negative 1.5 or greater than 10.5 would be an outlier. That makes 19 an outlier. If you look back at that original data set from just a second ago, 19 is the only number that falls into that, so it's an outlier. What we like to do to see the effect that an outlier has is remove from the data set, see what happens. Okay, and what you'll notice when you remove the outlier from the data set in general is that things like the median and the interquartile range don't usually change very much. But the mean and the standard deviation can change quite a bit. In fact, the mean here, when we took the outlier out, was less. Went from 5.4 to 4.3. And when we took the outlier out, our standard deviation was much less as well, almost half, from 4.3 to 2.2. So it had a huge impact on the mean and standard deviation. They are not resistant to outliers. Anytime you take an outlier out, you'll see that it has a huge impact on those measurements. So here's one for you to practice. We're going to use this data set to make a box and whisker plot and check to see if there are any outliers. So when we're making our box and whisker plot, we need to find the minimum, first quartile, median, third quartile, and maximum. We need to get a number line that will go from our smallest number to our highest number. And above that number line, we want to represent to the best of our ability where each of those 5 numbers are. Now, I want to show you what happens when you have an outlier. When you have an outlier, you represent that outlier with a little star or a little dot or a little some kind of symbol like that. and you leave a gap between the outlier and your very next highest, in this case, data value. So the next highest data value after 24 was 9. So I have a gap from 24 all the way to 9. That shows me that the rest of my data was way down here, and this outlier was way up here at 24. Now to find the interquartile range, you would subtract Q3 from Q1. You should get 3.5 when you do that. The first quartile was 5, the third quartile was 8.5, and the interquartile range, as we already said, was 3.5. Were there outliers? Well, we already see from our graph that there is an outlier. I should have done this first and then done the graph. Sorry about that. But our lower boundary is a negative number. We have no negatives up here, so our lower boundary doesn't show any outliers. But our upper boundary is 13.75 after using the formula we discussed a minute ago. And 24 is definitely more, and it's the only value more than that upper boundary for outliers. So since it's greater, it is an outlier. It's represented a little bit differently. So are there outliers? Yes, there are. 24 is greater than 13.75 and is an outlier. Well, ladies and gentlemen, that is it for today. This unit is going to be very different for you. There are some parts where we won't even do any math, and there's some parts where we'll do a little bit, but we're going to do about 2 or 3 weeks of statistics before we move on to our last unit and get back to some algebra.